So, hello, welcome back, students. Namaskar, Adab, Sat Sri Akal. I hope that all of you are good and doing good in your studies. So, if I'm talking about our last lecture, we have discussed about the series and parallel combination of current velocity. Yes, we have discussed about V-Stone, which very important one. Okay, we have discussed about different combinations that are possible in series and parallel combinations. Correct. Now in this lecture we are going to study about the combinations of batteries, of cells, resistors. These kind of combinations we are going to study, because I have told you about cell also, but because whenever their shell is coming, some internal resistance is also coming along with that, and that is what we are going to study in this lecture. So without wasting any further time, let's begin. Now see here, now we are in the topic combination of cells. So give your heading as combination of cells and start writing. First combination we are going to study is series combination, and the second thing that we are going to study today is parallel combination of batteries. What will be the results? How will be the results that we are going to understand here? See, if one terminal joined with the another, only one terminal of the other cell, then this kind of combination is called as series combination. For example, here you can see very clearly, here is a battery of E1 voltage, here is a battery of E2 voltage, here is a resistance R1, here is a resistance R2, correct? And they are connected end to end. That's why I can say this. What is this kind of combination? This is kind of series combination. Now second one is a parallel combination, that further in this lecture we are going to study what kind of results we will be getting in further parallel combination. Here you can say one terminal of the other of all cells should join together. Similarly, other terminals too should join together. See, terminals are joining together. Here terminals are joining together, or even better method to analyze this point is potential difference will again same. I have told you always, either it is capacitor, either it is battery, either it is resistor. Parallel combination always have a property that potential difference is going to be same, and the current that will be flowing will be different. Okay, so this kind of combinations you can visualize here, that these are the things. Now firstly let's start from series combination. What happened? Okay, I have not inserted this. Correct. So now in series combination also there are two kind of possibilities. On the basis of polarity, I will have again two kind of possibilities. What are the two possibilities that I am going to have? One will be either same polarity. See here, same kind of polarity, positive negative, here also positive negative. This kind of system is called as of same polarity, and the other possibility is of opposite polarity. Opposite polarity means what? Here it is higher potential, lower potential, and here it is lower potential and higher potential. So I can say the polarity have been changed in the second case. This kind of system is called as opposite polarity. So firstly we are going to understand for the same polarity, and then we are going to understand for opposite polarity as well. Okay, so let's see what will be the result. So if you want to find the effective EMF, what will be the, when you are applying two batteries, what is going to be the effective EMS? For that, what we have to do, we have to apply KVL. Let's apply KVL from point A to B. So this is the direction of current. I have applied you about KVL also. We have discussed in completed. What are the two things that you have to always remember, students? Tell me. If you are going from lower potential to higher potential, you will be always taking it as positive. And if you are going in the direction of current, you will always write the potential difference across the resistor as negative of I into R. Correct? So assuming those things, I hope that you have remembered the things. And I am going from point, I am crossing this battery. What I will write? Tell me. Firstly, I have started from point A. That means I will write the potential at this point is VA. Now, after crossing, I am going from higher potential to lower potential. That's why I am going to write it as minus of E1. Correct? Now, what is the next thing coming? Next thing coming is resistor of internal resistors R1, and I am going against the direction of current. That's why I will write it as plus of I1 into R1, plus of I1, or I simply you can write simply I into R1. Correct? Now, what is the next thing? Again, can you say I have a battery that I am going to cross? Again, from a higher potential to lower potential, higher potential to lower potential. Again, it is a negative. Then, what is the next thing coming in way? Next thing coming in the way is the resistor. That means what you will say, plus of I into R2, plus of I into R2 is equals to VB, is equals to VB. This is what you are going to write. Now what you will do, VA minus VB is equals to, here what you will say, here it is E2, change the side, what you will say, it will be E1 plus E2 in bracket, here what you will take, minus of I R1, minus taken common R1 plus R2. Now if you will be comparing, you remember what was the general relation I have told you about the potential and the EMF. The general relation was what? V is equal to I into V is equal to E minus of I into R, E equivalent into R equivalent. If you are comparing these two equations, a very good relation that you are going to get. This is delta V and this is the E equivalent. You can comparing, you can say E equivalent is going to be E1 plus E2, and if we are comparing this I coefficient, you can say R equivalent is equals to R1 plus R2, and I can say this is very obvious also, because this is a simple series combination. That's why resistors are already, we know the result for resistor, and from here also as well we are getting the same result. So always remember, for same kind of polarities, what will be happening, for same kind of polarities, simply add up them, E1 plus E2, and what will be the resistance? Resistance will be R1 plus R2. I hope that this is clear to you. See. Now, if n number of identical cells are connected in series with same polarity, then what will be happening? Of all the n number of cells are connected, then what you will do? For two cells, I have told you what is the result, E1 plus E2. So n number of cells, how you will write? E1 plus E2 plus E3, till where you will be writing? Till En. And if all of them are same, then simply can't I write this as n into E? I will simply write it as n into E. If someone asks me, tell me what is R equivalent, what I will write? All the connected connections are in series. That means what I will write? R1 plus R2 plus R3 plus Rn, and all the polarities are same. That means simply I can also write it as n into R. N into R. Is it clear? Very obvious things are there. So n non-identical cells are connected in series with the same polarity. That means of course you will be writing E1 plus E2 plus E3 differently and divide by resistance also. And that's why if you want to write current, don't forget to add this resistor also. This is the external resistor and all these are internal resistors. Okay. So for example, let's suppose if someone is asking me, at the place of this complete circuit, I want to replace, for solving purpose, always we try to decrease the size of the circuit. For replacing this complete circuit, I have to draw an equivalent circuit. How I will be drawing? Here it is what, 6 volt, here it is what, 4 volt, here it is what, 2 volt, and I can say polarity is going to be same, positive negative and positive negative. That is what I can say. The net battery EMF here, 6 plus 4, 10 plus 2, that is 12 volt. And what about the resistance? I can say 1 plus 2, that is 3, 3 plus 1, that is equivalent. I can say it is equals to 4 ohm. Is it clear? Is equals to 4 ohm. Now n identical cells are connected in series with same polarity. I guess that we have already discussed about it. Okay. That the result is going to be Ne and R equivalent is going to be Nr. Already we have seen about it. Now what will be happening if there is opposite polarity? What will be happening if there is opposite polarity? Okay. So let's again apply KVL from A to B. The same process that we have followed for the same polarity also. Now start from point A. Point A, firstly what you are going to cross? You are going to cross the battery. Now start writing. From point A to B, what is the first thing that you are crossing? You will write the potential difference. Firstly, you have started from point A. Now you are moving from see here. It is higher potential, and then you are coming to lower potential. Higher potential to lower potential, what you will be writing? Minus of E1. Then what is the next thing? R1, resistor. You are going in the opposite direction. That means you will write what? Plus of I into R1. Correct? Now the polarity have been changed. The next thing that we are going to write is, this is plus sign. That means you are going from lower potential to higher potential. Lower to higher, when you are going, you will be writing it as plus of E2 minus of plus of I into R2 is equals to VB. Correct? This is what the KVL I will be writing. Now what I will do? I will write VA minus VB is equals to, now check this time what is happening here. You will be writing, changing the side, E1 minus E1 minus E2, and taking E1 is coming positive here, and then the currents that you are going to take minus of I will be taking common R1 plus R2. So from here, what you are concluding, students? Tell me, what is the general equation that you write? V is equal to E minus IR, E equivalent, R equivalent. From comparing this, what I can say, E equivalent is going to be E1 minus E2, and R equivalent will be same because it doesn't depend on the polarity. There is no polarity for resistors. Polarity is for battery. That means the E2 that you have changed the polarity, now it will be just change the sign. E1 will be now at the place of E2 plus of E2, you will be writing minus of E2. That means simply remember, if you are changing the polarity, what will be happening? It will, from positive polarity, it will become negative polarity. That's it. That is what the change you have to do. There is no need of further thing into it. Same will be going for parallel combination also. There also we will be going to see. Okay. So let's suppose here, if I have to calculate what is the effective EMF of the battery and effective resistance, how I will be writing? Now see, firstly check the polarity. All these are connected in series. This is clear, correct now? Now check the polarities. This is higher potential, lower potential. This is lower higher, that means there is a change in polarity. I will write it as minus, and then again this is normal, higher and lower polarity. Is it clear? Correct. Now see, what I will do, I will simply write 6 volt as positive. I will have to write this as negative, minus of 4 volt, and this again I will write as positive. 6 minus 4, 2, 2 plus 2, that means I can say this is net equals to 4 volts. Net it will become 4 volts. And if I am talking about R equivalent, what I can say, 1 plus 2, that is 3, 3 plus 1, it is equals to 4 ohm. R equivalent is equal to 4 ohm. Is it clear? E equivalent 6 minus 4 plus 2, correct, and R equivalent is equal to 4 ohm. Simple as that. Now let's suppose this is the scenario. Then what will be happening? We are going to cover all the bases, and in the question series we are going to see in depth the application of these things. So as of now, just understand the concepts. It will be already I am taking all the variations that are possible in any kind of exams. See here what is given: n identical cells with same polarity and m number of same cells with opposite polarity. So this time we have taken both kind of combinations. If I am showing you in the diagram, all these n identical cells are in same polarity and these m identical cells are in opposite polarity. That means if I have to write the effective E equivalent, how I will be writing? I will multiply n times of E in positive sign, and here what I will be writing, minus of m times of E, This is what I am going to write for effective equivalent resistance. And what I can write for equivalent EMF, and what I can write for equivalent resistance, I will write simply n number of identical resistors are there. That means I will write n into R. Sorry, smaller I should write because it is a representation smaller. N into R plus of, and here effectively m number of resistors are there. That means m into R. This is what the result I am going to get. So you can cross check it also. Remember E n minus m as effective EMF, and for resistor what you will be doing, effectively n plus m. This is what we are going to write. Is it clear? See, n minus m into E, and here of course there is a resistor also, but I have not considered that. But if you are writing the complete current, you will be writing this R also. Okay, just simply add up and rest of the results is going to be same. Is it correct? Any doubt? So we have concluded for now the parallel combination. Again, now parallel combination will also have two kind of variations, one for same polarity, one is for opposite polarity. Now but this time it is very obvious for you as well that if there is opposite polarity, what I will do, I will simply attach a negative sign and that's it. My job is done. I don't have to think a lot about the negative polarity. Just simply the normal polarity, normally what it is going, and if there is a change in polarity, just apply a negative sign in front of that potential, and that's it. You will be having the correct answers. Okay. So let's see what kind of variations you are going to get. For derivation purpose, what is the effective EMF you are going to get in the circuit? Firstly, first step is apply KVL in path. In the first path, let's suppose here it is drawn A, X, Y, B. In this path, let's try to apply KVL. How will be writing KVL? Let's start writing. What is the first point that you are having here? Point A. just write the potential at point A. You will be writing VA. Correct? I told you two things that are important. What are the two things, students? Tell me. Correct. What are the two things? Firstly, when you are going from higher to lower, you will be writing negative, and when you are going from lower to higher, you will be writing it as positive. Correct? So let's see here. Now you are going in the against opposite direction of current. That means this is what VA. Now here also potential will be VA. Correct? Now what is the next thing that is going to come in your way? That is a battery from higher potential to lower potential. When you are going from higher potential to lower potential, what you are going to write? You will be writing it as minus. That means you will be writing minus of E1. E1 is given. Correct? Now what is the next thing that you are getting? You are getting a resistor. You have to write potential difference across the resistor. How you will be writing? You will be writing what is the current I1 into R1, and you will be writing it as plus I1 into R1. I1 into R1. And then you will be writing next point is at potential VB. That means what you will be writing the first equation, VA minus VB is equals to E1 minus of I1 into R1. This is the first equation that you will be getting. Correct? You can cross check it here also. After solving first equation, that you will be getting is V is equal to E1 minus I1 into R1. From there we have calculated what is going to be I1 current. We have calculated what is going to be I1 current. Correct? Now let's enter into the second part. Now apply KVL for the third equation. For the third equation, now let's apply KVL into this section. In which section now I am asking you to apply KVL? Apply KVL into A, P, Q, B. On this path apply KVL. Now let's again start from point A. What you will be writing? VA. This point is at VA. Now what is the next thing coming in your way? Next thing coming here is battery. You are going from higher to lower potential. That means again you are going to write minus of E2, and then the next thing is potential difference across this resistor R2. How you will be writing? Plus, because you are going in the against direction of current. Correct? Plus of I2 into R2 is equals to VB. VA minus VB will be represented as V, potential difference, because it is same for both the things. Now here what you will do, it will be written as E2 minus of I2 into R2. Correct? And if I have to write the current I2, how I will be writing? I will be writing it as E2 minus V divided by R2. This is what going to be my third equation. This is my current I2. Now I got my I1, I got my I2, and from this equation I can simply say, applying KCL at this node, what I can say, I is equals to I1 plus I2. Very simply it is written, the net current that is coming inside, it is going to be net current that is going outside from the node. Correct? Now just simply add up them. What is the result that you will be getting? You got both the things now. And what is the general equation that we know? Relation between potential and EMF. You know that V is equal to E minus of IR. E minus IR. Correct? So let's apply that. I is equals to I1. I1 is how much? E1 minus V divided by R1 plus E2 minus V divided by R2. Correct? Now I have to solve it, and I have to take the thing in the form V is equals to E minus IR. When you are solving this, the final result now I am writing, after solving you will be getting the result. When you are comparing these two things, this will be coming V is equals to E1 by R1 plus E2 by R2 divided by 1 by R1 plus of 1 by R2. This is the result, minus of I 1 by R1 plus of 1 by R2. Here it is not working properly. Here I am writing 1 by R1 plus 1 by R2. Correct? Now after comparing these two things, what is the result that you have to remember? That is very important result. Here I am writing E equivalent, you will be writing E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. And for parallel combination of internal relations, already you know what is the result. 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Now is it clear? I hope that now this effective resistance formula will be very much clear to you. Okay. So let's have some basic question based on this. Okay. After solving, you will be getting the same result that you have to remember. E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. Okay. And R equivalent will be 1 by R1 plus 1 by R2. Correct. Now let's have a question, okay, and try to apply the formula on this basic example, so that you can have the basic understanding of the formulas as well. Now here three batteries are connected in parallel combination, 9 volt, 6 volt and 3 volt, and some internal resistance are also connected, 3 3 3. Okay, and you have to calculate what is the effective EMF between A and B. What is the formula? E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus of 1 by R3. Correct? Now let's put the values here. Tell me, what is even, students? 9. 9 divided by 3, what will write? 3. Simply I am writing. Come here. Here what will writing? 6 divided by 3, eventually it will become 2 plus 3 divided by 3, 1. Divided by 1 by 3 plus of 1 by 3 plus of 1 by 3. Eventually it is going to become equals to 1. That means what is the effective EMF that is going to come? 3 plus 2 plus 1, that is 6 divided by 1, that means 6 volt is the effective EMF. And what I will ask you, what is the R equivalent? R equivalent you will be saying 3 3 3 in parallel, that means effective resistance is very easy, it is going to be 1 ohm. That means at the place of this complete circuit you can draw a single circuit of EMF 6 volt and internal resistance 1 ohm. See how simplified it becomes. This much of complicated circuit that is looking, you can replace this complete system by a single battery, single resistance. Isn't it very good? Isn't it making the questions very simple looking? Correct? And that is what the step for good questions in when you are solving any circuit. These are the things that are going to help you. Right? Good questions, I am telling you. Otherwise, directly also by just using the formula, most of the questions will be solved only. Now come for opposite polarity. What I have told you for opposite polarity, whenever there is a change in sign of from normal polarity, just apply a negative sign, that's it. And that is what here also we are going to do. See, what is the case here? Here it is positive, negative, correct? But here they have given negative, positive. That means it is a opposite polarity. That means the same formula I am going to apply, but here I am going to apply a negative sign in the front of E2. Correct? Now let's understand this by an example. It will be better clear to you. Correct? Understand it? How you will be writing? Same example that the last case we had, but this time E equivalent is going to be changed. Now, what is the formula? I hope that you will already remembering. E1 by R1. E1 by R1. What is the ratio is going to come? And polarity is positive. That's why I will be writing 3 directly. Now, E2 by R2 is 2. But here there is a negative sign and then positive sign. That means it is change in polarity. That means I will be writing here it is -2. Here it is again positive, negative. That means same polarity, plus 1. Divided by effective resistance. You remember from the last question, it is 1. 3 minus 2. That means effectively what is the EMF that is going to come? It is equals to 2 volt. And R equivalent is simple. R equivalent is equals to 1 by 3 plus 1 by 3 plus of 1 by 3. Eventually it will become 1. Here is the, so this complete system can be replaced by this one. Now only thing that you have to be very careful about when solving this circuits is about polarity. Once you made a mistake in polarity, the complete answer is going to be wrong. So always cross check the polarities. Okay. It should be in the same sequence always. Okay. So here the some results is given to you. Let's suppose what will be happening if n number of batteries are connected into parallel combination. So what will be writing? E1 by R1 plus E2 by R2 plus E3 by R3, and all are identical. So better than writing it, multiply n times of E by R divided by n times of 1 by R. This is what the result that is going to be equal. N E by R divided by N by R simply, and R equivalent will be, you already I have told you for parallel combination what is the result that is going to happen. Correct? Don't get worried for this large number of if large number of batteries are connected, large number of series are connected, combinations are connected. This kind of questions are even more easier. It is just giving you to horrify you from the question, that you will get horrified by the question, looking at the question, that it is very tough that you cannot solve. But I am telling you honestly, most of these kind of questions are more easier even. Okay. Here there is another case also. n identical cells with same polarity and m same cells with the opposite polarity, it is connected. So what you'll be writing the effective, you'll be adding all these things and you'll be adding all these things, but in front of this there will be a negative sign, so eventually it will become n times of E by R minus of m times of E by R, and in denominator what you'll be writing 1 by R, n by R minus plus of m by R. This is what the result is going to be for E equivalent when you will be writing, correct? So from R will get cancelled, but this is the result that you will be getting. This R will simply get cancelled out, and from here what you can say, E will be coming common, n minus m divided by, here what I will be saying, m plus n. This is the final result that you will be getting, correct? Now this is the summary of the formula that I have explained you. Now based on that, let's solve this basic question, okay, so that you can have a summary of all the things that we have studied till now. Find the equivalent EMF and equivalent resistance of the given combination of cells. Okay, this is the combination that is given. Firstly, identify what kind of combination it is given. Here it is, these two are in parallel combination and this along with this is in series combination. Now check the polarity. Here what it is, this is negative positive, and here what it is, what positive negative. That means I can say that there is a change in polarity here, so be careful about that, correct? So let's firstly solve this parallel combination and let's see what is the effective circuit I can draw for this one. So what is the formula? Let's put in the formula. E1 by R1, E equivalent I will be writing E1 by R1. E1 by R1, how much I can say? E1 is 10, R1 is 2, that means effectively I can say 5. Now when I am writing R1, what will be there? 4 by 2, but there is a change in polarity, that means I will write minus of 2 divided by, what is the equivalent resistance I can say, students? 2 ohm 2 ohm in parallel, that means eventually it is going to become equals to 1 ohm. That means what is the effective EMF that is going to come from this much? This is 3 volt, and R equivalent from this will be coming, already I have told you this is going to be 1 ohm. That means effectively for this circuit I can draw, there is a battery of who is in majority, this one is in majority, I can say. This is 3 volt, correct? How much it is coming? So see, here what you can write, here it will become 3 volt, and what is the effective resistance that you have calculated? That is equals to 1 ohm, correct? Now see, the majority is in negative, correct. So majority is there for this polarity. So which one will be having higher magnitude? You have to draw that in that direction. You will be drawing this as negative, this as positive, and there is an internal resistance. And what is the magnitude wise? Magnitude wise it is 3 volt, and what is the effective resistance? That is equals to 1. And now this is connected with this 6 volt, this 3 volt. Can you say again there is a change in polarity now, but now it is in series combination. That means final answer E final, it will be equal to 6 minus of 3, that is equals to 3 volt, and R equivalent will be equals to 1 plus 1, that is equals to 2. 3 comma 2, 3 comma 2, 3 comma 2. This option A will be the correct answer. Is it clear? We have checked all the things. We have checked parallel series also. We have checked the same polarity, different polarity. We have discussed the combination of cells in complete depth. No one will be telling you in this much of depth about the combinations of cells. Most of the people just tell you about the formulas and then they just skip this topic. Okay, but we have discussed in complete depth about all the aspects that can possible. Correct. Let's discuss a little bit about power. Okay, what is power? Power, if I am entering into the formulas directly, because power directly you need to remember the formulas. Definition wise, if I am going, it is defined as the rate of doing work is called as power. Rate of doing work is called as power. So what is the formula? If I am telling you about power, power is defined as V into I. Potential into I. From the basic classes you are studying this formula, so there is nothing new in this section. You know already all the formulas that are present here. SI unit of power, if I am talking about, SI unit of power is what, and I have told you that it is defined as rate of work done, that means work done by time it is defined, that means also it is defined as work done is what, joules energy, and this time is, so it is also defined as joule per second and or simply we give a very famous term is there, watt. So power always gets dissipated in resistor in form of heat, because you know that what is the property of resistor? To oppose the flow of current. That's why always there is some heat that is generated, and that is dissipated form of heat and light. Okay. So let's see how much that heat is also radiated there. So for that, firstly before that, let's see all the formulas for power. Power, I have told you the first formula that you have to remember is power is equal to V into I. Now you know about, if you want to replace this V, what you can say, V is equals to I into R. So replace this value here. What you can say further, I square R will become, if you want to replace I can be written as V by R. So replace that value, you will be getting power is equal to V square by R. So all these three formulas are important. On different cases, you have to apply the different formulas. Correct. Now if someone asks you how much heat is dissipated in time t, how you will be writing? Power is defined as rate of doing work. Correct. And what you have written for this, you have written this as dW as V into I power, and you will be integrating it with dt. So you here what you can do, just integrate it. The pen is on. So energy, if you want to write, how you will be writing? D P is equal to dW by dt, or this work done is going to convert it into heat loss, that is going to happen. That means you will be writing dP into dt, it is equal to dW. So integrating both the sides, it will become total heat that is going to be dissipated, and here it is what, V into I, that is power, into dt, integrated from 0 to till time t. That means heat can be written as integration of dt is going to be T V into I into T. This is the result that you are going to get, V into I into T. I hope that in the basic classes also you have already studied about this formula. Same formula can also be written as I square R into T, or it can also be written as V square T divided by R. Correct. That means you just have to multiply a factor of time there, and that's it, that you will be getting the heat formula. Is it clear? Is it correct? So this is all the formulas that I have summarized at a single place. This is for formulas for power, and this is all the formulas for energy. So these are the important formulas that you have to remember. Okay. Now next thing is, at what condition you will be having maximum power. For that also I am explaining you how you will be doing. If I ask you power, how you will be writing power? Power can be written as I square into R. I square into the resistance. What is I square? You will be writing. Current will be written as, what is the effective current here? How much current will be flowing? What is the effective EMF? E divided by what is the effective resistance? I can say there are two resistors and both are connected in series. That means R plus R. R plus R. This is what the current that we are going to write. And I square R, that means it will be eventually become E square divided by R plus R whole square into R. This is power. And if you want to maximize, anything, let's suppose there is an equation in y and you want to maximize that, how you will be doing? Remember the starting lectures of basic maths, how you will be maximizing any value? For maximizing any value, just differentiate it with the variable and making it is equals to 0. That means what you have to do? You have to do dp by dr is equals to 0. dp by dr is equal to 0. Here is the complete calculation, and when finally you will be solving it, you will be getting the results. R is equal to R. When the small r is equals to capital R, at that moment you will be getting your maximum power. Okay, so there is a curve also that you should understand. Okay, there is a variation of power with the resistance, and at what point you will be having its maxima? You will be having its maxima at R is equals to small r, and this was the result. That means maximum power will be how much? E square satisfy R is equal to R. That means here it will become small r divided by here it will become 4 R square. This R will get cancelled. E square divided by 4R. This is what your maximum power as well. Okay. And at what point it is achieved? At R is equal to capital R, the maximum power is going to be achieved. Correct. So now let's discuss a little bit about equivalent power, how you will be writing equivalent power. Okay, if I'll ask you, there are two circuits that I have shown you. Here the battery is V, here also battery is V, and here resistor is R1, here resistor is R2. How you will be writing the power across this one? You will be writing power P1 is equal to V square by R1. Here you will be writing power P2 is equal to V square by R2. Correct? And now if I will be writing, I will be connecting these two in series combination. How you will be writing the effective power? That is the one thing that you have to understand. If I'll ask you, tell me how you'll be writing R equivalent, equivalent resistance, how you'll be writing R equivalent, you'll be writing R1 plus R2, correct? And how you write power? Power is written as V square by R equivalent, correct? So just replace this value. R equivalent, how you'll be writing R equivalent, you'll be writing P square divided by V square divided by P equivalent is equals to. If I'm asking you to write R1, how you'll be writing R1? R1 will be written as V1, sorry, V square divided by R1 plus R2. How will be written? Here it is P1, V square divided by P2. V square will be simply get cancelled out, and you can write here 1 by P equivalent is equal to 1 by P1 plus 1 by P2. Correct? This is the series combination, and for parallel combination, same way you can say. For parallel combination, how you will be writing? If I am asking you what is R equivalent, what you will be saying? R equivalent is equal to say 1 by R1 plus 1 by R2. And what you say about the result? P is equal to V square by R equivalent, here P equivalent. If I am asking you write R equivalent, how you will be writing? R equivalent will be written as P equivalent, sorry, V square into P equivalent. Here if I will be asking, you will be writing V square divided by P1 plus here you will be writing P2 divided by P2 square. V square will cancel out. P equivalent will be equals to P1 plus P2 for parallel combination. This is what the combination that you are going to write. Clear? So this is it for this lecture, and in next lecture will be the final lecture that we are going to cover for bulbs. We are going to see more about galvanometer that I have told you. So, and some more combinations we will be looking at what are the more variation of questions that are possible. That will be the final lecture for current electricity. So until next time, keep learning, keep going with tapasya, endigo and then devo with nama tapasya.